Okay, audible and visible.
Yes, sir.
Okay. So basically, if you see, हम लोगों ने जो last time discuss किया था, we were talking about case number 7 and 8, in which we had two weak monoprotic acid in case 7 and two weak monoacidic base in case 8, है ना? और इन दोनों में the common thing was that if I'm talking about case 8, it was having H plus ion का concentration equal to under root K1C1 plus K2C. Similarly, in case 8, we'll be having OH minus का concentration is equal to under root Kb into C का summation, है ना? That is Kb1C1 plus Kb2C2. That was the basis, and we have talked about the ions concentration also. Now, while you observe all these cases, particularly 3 से लेकर 8 तक, 3 में we were having some weak acid only, but that was weak monoprotic acid. Case 4 was pair of that, it was having weak mono acidic base only. Case 5 was weak monoprotic acid plus strong acid. And then case 7 was weak monoprotic acid plus another weak monoprotic acid. Hai na? So now, if you see, we have covered all those cases in which acid and base are not coming together. Hai na? We are having either acid only or base only or combination of acids and acids or combination of bases. So far, we have not interacted or we have not discussed any case in which acid and base will be coming together. First thing. Second thing is, whenever we were having weak acid, it was always weak monoprotic acid. And whenever we were having weak base, it was weak monoacid base. Now we want to discuss case number 9 and 10, in which we'll be talking about, like, if I am having a weak monoprotic acid ki jagah weak polyprotic acid, then what will happen? We'll discuss that, and based on that similar manner, we can handle the weak polyacidic base ka case bhi. Okay? So we are going to talk about case number 9, in which I'll be talking about if I am having a weak polyprotic acid. So weak polyprotic acid mein, if you see na, you'll be having, if you see weak polyprotic acid, it can be, normally it is generally diprotic or triprotic. Now, theoretically, to you can have quadruprotic also, but generally we don't get that practically. Particularly ionic equilibrium में तो बिल्कुल नहीं बात करते हैं. So इसमें से, if you see H2C2O4 is oxalic acid, the structure is like ऐसा कुछ जाता है. So we say both the hydrogen are acidic hydrogen, and that's why we say that this is a weak diprotic acid. H2S में we can see both the hydrogen atoms are bonded with S. Not very strong acid, but still we consider it as a weak diprotic acid. So दो H plus दे सकता है, ये release कर सकता है. H2CO3 में we have got the special case is of S3PO3, in which we can see 3 hydrogen atoms, but 2 of them are only protic. So earlier also I have given you the example यहाँ क्या लिखा, each step attain, ये missing. So basically, if you see the structure of S3PO3, it is like this. And that's why we are saying only 2 hydrogen atoms are acidic, and that's why even if S3PO3 is having 3 hydrogen atoms, only 2 are acidic. So it is a weak diprotic acid, not triprotic acid. S3PO4 is having all the hydrogen protic, because the structure of this was S3PO3. If I'm talking about S3PO4, now it is having all the hydrogen bonded with oxygen only. And that's why we will say this is a weak triprotic acid. I'm giving you triprotic example. Similar manner you can handle triprotic, because triprotic में the first point is we say that polyprotic acid will attain equilibrium or will release H plus in stepwise manner, and that's why every step will be having reversibility. So every step will attain or will achieve or will reach equilibrium state. Is it okay? Like if you see step 1, H3PO4 is releasing its first H plus. Now the formed product other than H plus is H2PO4 minus. That H2PO4 minus will release another H plus, and that will form HPO4 2 minus. Then again, third, which is the last H plus, will be released by HPO4 2 minus, and it will produce H plus and PO4 3 minus. So we have got 3 steps. Each step has got reversibility, and that's why each step will have some equilibrium constant, and each step will reach the equilibrium state. Is it okay? Clear यहाँ तक? Now, इसमें कुछ important points हैं. What are those points? First, we'll see that. So, The first important point is somehow, एडवांस की तो बात नहीं है, बट somehow if they are asking you मेंस वाले क्वेश्चन में तीनों रिएक्शंस को ऐड कर दिया, के पे क्या इम्पैक्ट आएगा? If I add these three reactions, what will the final reaction if I add it? बताओ जरा.
The K equilibrium was the final reaction.
No, I'm just saying कि what will be the overall reaction?
H3PO4 giving 3H plus and PO4 3 minus.
Okay, because this will get cancelled, है ना? This will get cancelled if you are adding these reactions. So we'll say S3PO4 aqueous will be giving you 3H plus aqueous plus PO4 3 minus aqueous. And now if I ask you what will be the equilibrium constant for this reaction?
K1, K2, K3.
Yes, because when we add the reactions, K get multiplied, है ना? Clear ना सबको? Now, can we say phosphate ka 3 times will be the production of H plus? Harsh is saying
Yes, sir.
right. Yes. Baki koi? If you have another answer or same answer, you can give it. Om, can we say phosphate ka 3 times will be the production of H plus?
Nice, sir.
Why not?
So because like first, second और third step में से like H plus जो release होता है वो like कम होता जाएगा ना.
So,
So 3 times नहीं होगा, 3 times से कम होगा.
H plus will be less than 3 times. That you are saying.
हाँ.
Okay. Anyone else? Risha, Om, Geek, Anurag, any answer? I am asking you to compare the concentration of H plus and 3 times the concentration of phosphate. Should I put equal, greater, or less?
So 3PO4 3 minus will be more.
You are saying this.
Yes, sir.
Okay.
Sir, I think,
Ha, Prisha,
sir, I think the same.
you'll take the same. Okay. Geet,
So I'm confused. मुझे समझ नहीं आ रहा.
okay. You are not able to get the question or you are not able to get the answer.
Yeah, I understood the question, but answer मैं articulate नहीं कर पा रहा.
ठीक है. Harsh,
I think ulta hona chahiye, like H plus is greater.
why?
Sir, because H plus is being liberated at every step, whilst PO4 3 minus is only being formed. PO4 3 minus is only being formed at the last step.
Okay. तो लास्ट स्टेप में कुछ आया है ना H प्लस, इसलिए तो मैं 3 टाइम्स बोल रहा हूँ ना. आई एम नॉट सेइंग कि इक्वल है. आई एम नॉट कंपेयरिंग दिस विद दिस. आई एम कंपेयरिंग 3 टाइम्स ऑफ फॉस्फेट विद H प्लस. Okay, Prisha is also saying H plus should be less. Okay, that's one important learning we are going to get through calculation. तो देखेंगे ही देखेंगे. But I'll give you two things. एक जो लास्ट केस मैंने डिस्कस किया था ना, ये जो केस हम लोगों ने केस 7 and 8 डिस्कस किया था, इसका एक शॉर्टकट है दैट इज गिवन बाय चार्ज बैलेंस. ठीक है. फर्स्ट विल डिस्कस दैट चार्ज बैलेंस मेथड एंड देन विल गेट एवरीथिंग. तो ये जो केस 7 का ये फॉर्मूला जो आया था ना, H प्लस गिविंग अंडर H प्लस इक्वल्स अंडर रूट K1 C1 प्लस K2 C2, इसकी एक थ्योरी है. देयर इज अ शॉर्टकट टू दैट फॉर्मूला which will be obtained by something called charge balance method, and that will give you the answer of this question also. First we'll understand what is charge balance method. ठीक है. And then I'll give you the right answer as well as the explanation. Yeah, Harsh, bolo.
So, sorry, can we say that PO4 3 minus will be greater than concentration of H plus, because in the second and third step, when H plus is being liberated, there was already some H plus in solution. So equilibrium constant is getting, I mean, it is, the equilibrium is shifting backward.
तो थर्ड स्टेप का भी शिफ्टेड बैकवर्ड होगा ना.
Yes, sir. So PO4 3 minus should be greater than concentration of H plus.
Phosphate will even be less ना. थर्ड स्टेप में तो phosphate is also the product. Then okay, let's see. So a charge balance method is simple thing. Any aqueous solution of anything is net neutral. ठीक है. है ना? Agree na? H2O net neutral. Even if I put NaCl inside it or HCl inside it, the same number of cationic and anionic charges will be appearing. That's why net charge will still be zero, है ना? इसका मतलब है, we'll say concentration of, if I am talking about per unit volume, concentration of positive charge will always be equal to magnitude of, या फिर concentration of, I can say concentration of negative charge. Is it okay? Example, जो केस नंबर 7 किया था वही एक एग्जांपल ले लेते हैं. फर्स्ट एग्जांपल इज, if I am having aqueous solution containing कुछ भी एक HA ले लो and HA dash, ठीक है? What are the sources of positive charge? Positive charge,
H plus.
it will be H plus. Anything else? नहीं ना? H plus is the only substance which is bringing positive charge in the solution, and H plus is having just one positive charge, है ना? That's why we'll say 1 into concentration of H plus will become the concentration of positive charge. Okay, what are the sources of negative charge?
A minus, A dash minus,
Anything else?
OH minus.
Water is the source of OH minus also ना, ज़्यादा कम नहीं बात कर रहे हैं, but it will be there ना. So we'll write this will be equal to concentration of A minus into 1 plus 1 into concentration of A dash minus, plus it will be 1 into concentration of OH minus. Is it okay? Now, if you know, हम लोगों ने लिखा था K1 जब लिखा था, that was H plus into A minus upon HA लिखा. Ka2 can be written as H plus into, at equilibrium obviously, A dash minus upon HA dash, and OH minus तो KW upon H plus होता है. So we can write this one as H plus is equal to A minus, देखो क्या हो जाएगा, it will become Ka1 into HA upon H plus, okay, plus just one. Yeah. So basically, similarly, we can write Ka2 into HA dash upon H plus, plus this is Kw upon H plus. Now we can bring H plus on the left side. So that gives you H plus का square is equal to Ka1 HA plus Ka2 HA dash plus Kw. That means H plus is actually equal to under root Ka1 into HA का concentration plus Ka2 into HA dash का concentration plus Kw. Now, if you remember last time when we had discussed the case 7, we talked about कि whenever they are asking, they consider alpha 1 and alpha 2 be much less than, है ना? ये चीज करके हम लोगों ने फाइनल फॉर्मूला निकाला. That means concentration of HA and concentration of HA dash was C1 and C2 only. Even after dissociation or ionization, we can consider that. And that's why if I write that in this case for alpha 1 much less than 1 and alpha 2 much less than 1, we can write H plus will become under root Ka1 C1 plus Ka2 C2 plus KWR. Normally you'll be getting KW का value much less than, है ना? ठीक है? If it is less than 1/10 of the remaining part, तो we can ignore it. और ये एसिडिक सॉल्यूशन है तो डेफिनेटली वी नो दैट ये 10⁻14 तो काफी कम रहेगा ही रहेगा ना. दैट्स व्हाई सो वी कैन नेग्लेक्ट दैट. Is it okay? Can you apply this thing, the same charge balance method for aqueous solution containing S3PO? Can you apply this? Try करके बताओ जरा मेरे को. And relate the concentrations. Just like मैंने जो यहाँ लिखा है ना, this part, try to get the expression like this. हाँ क्रिश.
सर वो मतलब इसमें जो H प्लस का कॉन्सेंट्रेशन है इसके कॉन्सेंट्रिक स्टेप्स के बाद, राइट, वो कम होता है क्योंकि वो मतलब कॉमन आयन इफेक्ट होता है ना.
Okay, theoretically you want to understand कि धीरे धीरे क्या होगा, तो obviously every next step will have suppression in ionization due to the common ion effect imposed by the H
तो
plus of the.
लाइक बैकवर्ड शिफ्ट थोड़ा होगा ना वैसे इसके लिए.
वो सब तो कहानी हो गई, वो हम लोग समझेंगे. बट राइट नाउ आई
हाँ
एम टेलिंग यू जस्ट टू अप्लाई द चार्ज बैलेंस मेथड फॉर aqueous solution containing S3.
हाँ
Just apply, it will give you the mathematical answer.
हाँ सर.
Like what are the cations? What are the
Only H plus.
cations? Only H plus. What are the anions?
PO4 3 minus,
PO4
OH
माइनस एंड OH माइनस.
बस. बाकी सब remember
बट
this
एंड में बाकी सब बचेंगे ही नहीं ना.
was happening. ये सब नहीं बचेंगे तो फिर इक्विलिब्रियम कैसे आएगा? तुमने रिएक्शंस ऐड कर दिया, इसका मतलब जो एडेड रिएक्शन ये होगा, ये जरूरी नहीं, ये तो होगा ही नहीं. ये तो एक थियोरेटिकल कैलकुलेशन था कि इफ आई आस्क यू इफ this type of reaction I am giving you, what is the equilibrium constant for this type of reaction? This is not happening actually. The actual thing which is happening is these three steps. And that's why you are having this anion, and this anion present in the solution. Understood now? And that's why if I have to write the charge balance method for this case, I am having one cation which is H plus only. But I am having actually तो चार anions है, तो सबको लिख लेते हैं. I am having one anion like H2PO4 minus. So if it is having just -1 charge, so 1 into. If I am having HPO4 2 minus, every ion will give you 2 negative charge, no? That's why we need to multiply it by 2. Plus I am having phosphate ion, so I need to multiply it by 3. Plus I am having OH minus, so I need to multiply by this. Is it okay? Now if I ask you compare H plus and 3 into phosphate, what will you say?
H plus is greater.
It is total, it is just a part of this addition, no? And that's why Hence we can, एक तो ये equation आ गया, ठीक है, that's one part, but we can also say H plus is definitely going to be bigger than all these terms. In fact बाद में मैं बताऊंगा, ये तो बहुत ज्यादा, ये तो 3 times करके मैंने इस पे राम खाया, because we are getting that type of reaction जिसमें 3 times दिख रहा, but it will be much greater than, in fact बाद में देखेंगे, it will be much greater than phosphate ion के concentration के 3 times. ठीक है, that's one part. Understood ना? Prisha, Om, Anurag, clear क्या?
Yes, sir.
Prisha,
Yes,
Anurag,
sir.
clear na? Okay, now if I have got these type of conditions, now how to do the calculation? लेकिन पहले चलते हैं वही important notes में जिसकी बात मैंने की थी, how to understand those notes. Which important part है, then we'll do the calculation. So we'll be talking about 3 important notes. First thing is, if they are asking you the overall reaction ka K, then obviously we have added the reaction, so we'll be multiplying the K. But this is not the reaction happening actually. It is happening in stepwise manner, and every step is going to achieve the equilibrium. So it doesn't mean that कि यहाँ phosphate जितना बनेगा उसका 3 times H plus बनेगा. It will be much more than that we have seen from here. And बाद में calculation से number से भी देखेंगे, ठीक है? That's one part. Now इसी को reaction से कैसे समझेंगे? Why we are saying ये 3 times से भी ज्यादा होगा? The first step का equilibrium will be achieved, then the produced H2PO4 minus will be equal to the produced H plus in the first step. Only a part of that is again ionized, is producing H plus, and then HPO4 2 minus is produced. Only a part of HPO4 2 minus is producing H plus and PO4 3 minus. Is it okay? It's like मान लो 0.1 मोल जो है ना वो आयनाइज हुआ, उसका लाइक 20% ही फिर से आयनाइज हुआ, बट फिर से H प्लस मिला, और फिर उसमें से जो बचा हुआ था दैट इज प्रोड्यूसिंग PO4 3 minus. Is it okay? And that's why every time you'll see that because of the common ion effect imposed by step 1 and 2, step 3 will be highly suppressed. तो step 3 में H plus और PO4 minus 3 minus जो बन रहा है वो दोनों बराबर बनेगा, बट वो अमाउंट प्रीवियस स्टेप के H plus से काफी कम होगा. ठीक है, तो that is the theoretical or qualitative explanation. Okay, understood now? So that's why we are saying कि already I have proved you by the charge balance method that H plus is going to be much greater than 3 times of phosphate. Is it okay? But theoretically if they are asking mains का एक question कि तीनों reaction का तीनों step का Ka values are given, what will the overall Ka value of for the ionization of H3PO4 in this manner? It is not the actual manner in which H3PO4 is going to be ionized, but if they are asking you इसका equilibrium constant कितना, तो definitely will say K1 into K2 into K3. Is it okay? Second part, because once the H3PO4 is releasing one H plus, it is getting an anionic charge. The release of next H plus will become more difficult. And then again उसके बाद H plus release करने के बाद जो anion बन रहा है that has got -2 charge, तो release of H plus from that is even more difficult, and that's why we are saying K1 will be found to be much greater than K2 will be much greater than if there is some K3 or K4. So this will be the series which we are going to get practically. ठीक है, तो much greater than का मतलब है 10 times से ज्यादा होना चाहिए, तो much greater we call it much greater. ठीक है, that's second part. Third part is, now we have got 3 steps, and in the 3 steps we have got the पहले का equilibrium constant is the highest one, much greater than the remaining K. तो इसका मतलब है H plus produced in the first step will be much greater than the H plus produced in the remaining steps. That is first point. Second point is, जो जितना H plus निकालेगा उतना ज्यादा common ion effect बाकी steps पे लगाएगा, and even because of that also second and third step का H plus can be neglected in comparison to H plus from the first step. And after that, if I am saying it is only the first step which is releasing H plus practically, so forget the remaining steps just for the calculation of H plus. And if you are forgetting the remaining steps, it becomes a weak monoprotic acid only. Na? Is it okay? And that's why, iske baad, if I have to find out the calculation for H plus, what I'll do now, I'll just consider first step in this case. I'll say this is producing H plus H2PO4 minus. and it is having some K1 value, and this goes back to case number 3. Then we had learned that if this was C before ionization, if this was C00 अगर लिख दिया तो at equilibrium we were saying ये actual नहीं है, approximated calculation है, because इसके बाद भी तो further H2PO4 minus will be releasing, but वो सब steps neglect कर रहे हैं just for the calculation of H plus. बाकी calculation आगे करेंगे हम लोग. So we are saying that first step का alpha is alpha 1, this will become C alpha 1, this will become C alpha 1, है ना. बाद में ये जो आगे आयनाइज होगा ना उसका आयनाइजेशन इतना कम है कि वी कैन नेग्लेक्ट दैट प्रैक्टिकल. इज इट ओके? एंड दैट्स व्हाई एट इक्विलिब्रियम, इफ यू रिमेंबर जो कहानी हम लोगों ने मोनोप्रोटिक में की थी वैसे ही कुछ कहानी आएगी. दिस विल बी द इक्वेशन व्हिच यू हैव टू सॉल्व इट, बट के की जगह K1 हो गया, अल्फा की जगह अल्फा 1. नाउ इसके बाद हम लोगों ने बताया था कि इफ अंडर रूट के अपॉन सी चेक करते थे, यहाँ विल चेक अंडर रूट के अपॉन सी, K1 अपॉन सी. If that is less than 0.1, say we say that alpha 1 will be under root K1 upon C, and then यहाँ से H plus will become under root, this is from acid, will become under root K1 into C. हाँ क्रिश बोल.
सर कोई ऐसा केस हो सकता है जिसमें वी कैन नॉट इग्नोर द H plus from other two ionization steps?
हाँ आएगा ना, आगे आएगा.
Okay.
आएगा, घबराओ मत, आएगा. Okay, understood ना अभी तक this point? Now this is the first case if it is less than 0.1. Now if you can have an acid जिसमें ये greater than 0.1 आ जाए, अगर ऐसा आता था तो वी हैव लर्न दैट इफ इट इज कमिंग, चलो इक्वलिटी तक वहीं रखते हैं, इजियर रखते हैं. अगर ग्रेटर हो गया तो फिर वी से दैट यू हैव टू सॉल्व द क्वाड्रेटिक, है ना. आई एम कॉलिंग इट इक्वेशन 1. सॉल्व इक्वेशन 1 टू गेट अल्फा 1, एंड देन we'll say H plus from acid will be C alpha 1, है ना. And then we can calculate the pH, but before checking the pH we need to always see that whether it is greater than 10 raised to minus 6 or not, नहीं तो फिर water वाली कहानी आती है ना. Is it okay? Now I'll give you the values of these three steps का K का values for S3PO4. Just see if I say K1 is like 10 raised to minus 3, range में दे रहा हूँ, rough value दे रहा हूँ. K2 is 10 raised to minus 8 and K3 is 10 raised to minus 13. See the range. वैसे ही H2CO3 के लिए will be getting 2 K values. One is in the range of 10 raised to minus 7, another is in the range of 10 raised to minus 11. तो 10,000 टाइम्स लेस है, तो डेफिनेटली वी कैन इग्नोर द रिमेनिंग स्टेप्स, है ना. तो प्रैक्टिकली जितने एसिड्स मिलते हैं ना, यू कैन establish this fact that K1 is much greater than K2, that is much greater than K3. So practically we can calculate H plus or pH from the first step itself. But if I ask you calculate the concentration of H2PO4 minus, calculate the concentration of HPO4 2 minus, calculate the concentration of PO4 3 minus, then we need to do some calculation. So I'll be talking about calculation of anions. Okay, just 1 minute wait and just try to think about it. मैं आता हूँ 1 मिनट, कोई तो आया. Okay. Now, if you see this calculation, if I have to do the calculation for the anions, every step is reaching equilibrium state, है ना. ये जो हम लोगों ने लिखा है every step is reaching equilibrium, तो at equilibrium we can write K1 will be H plus into H2PO4 minus by H3PO4. Similarly we can write K2 will be H plus into HPO4 2 minus by H2PO4 minus, है ना. These type of things we can write, है ना. तो we'll be doing that calculation only. So if you see step 1 itself, यहाँ जो लिखा है whatever is the value of H plus approximately same will be the value of H2PO4 minus only, क्योंकि सेकंड स्टेप में आयनेशन को इग्नोर किया था, नेग्लेक्ट किया था ना. एंड दैट्स व्हाई if I have to write H2PO4 minus in this case, I'll simply write it will be equal to H plus, very close, slightly less but very close to H plus, and that's why we have done that calculation H plus का. Now if I talk about, तो ये फर्स्ट स्टेप से हम लोगों ने ये लिख दिया. If I'm talking about second step का calculation, now we can write ना, second step में the products were H plus and HPO4 2 minus. The reactant was H2PO4 minus. So this is equal to K2. अभी जस्ट क्या देखा है, ऊपर ही क्या देख पा रहे हैं हम लोगों ने, ये और ये बराबर लिया ना. That gives you simply, that gives you that HPO4 2 minus HPO4 2 minus will be very close to K2 itself. And now see the number. K2 is in the range of 10 raised to minus 8. Even if I give you na 0.1 m aqueous solution of H3PO4, H plus देखो कितना आएगा इस calculation से, it will be coming 10 raised to minus 3 into 10 raised to minus 1. So that will be coming 10 raised to minus 2. और यहाँ ये आ रहा है 10 raised to minus 8. Definitely we can ignore the H plus coming from this step, है ना. So that's another part. Now third step में similar manner में, yeah Harsh?
Sir, in the second step, the H plus that the concentration of H plus is H plus from the previous step plus H plus liberated from H2PO4 minus, right?
No. Whenever we write concentration as an active mass in any expression of Q ना, we take the net.
Oh, okay.
Total. जहां भी लेते हैं simultaneous equilibrium से मैंने बोलना स्टार्ट किया है. So whenever we will be having any substance present in equilibrium, so while writing the active mass, we always take the net active mass of that substance in every Q. ठीक है? So
So
now,
these steps are not happening one by one.
huh?
These steps are not happening one by one. Like the concentration of H plus is already a certain total.
We are theoretically writing it in step-wise manner. तुम्हारे पास सॉल्यूशन दिया, अंदर कोई नहीं देखने जा रहा है. You will be having all these ions present in the solution, है ना. ठीक है? So now,
So immediately it will be the total.
हाँ, immediately क्या मतलब, whenever we will be writing at equilibrium, you are writing, है ना. So at equilibrium, what is total H plus? So we have considerably understood that की H plus from the first step will be almost the H plus from all the steps, है ना. ठीक है? And that's why we are taking net one. Now this part will have HPO4 2 minus, sorry, phosphate is the product. PO4 3 minus upon HPO4 2 minus will be Ka3. And now, so PO4 3 minus will become K3 into HPO4 minus का वैल्यू हम लोगों ने K2 लिखा हुआ है यहाँ पे ना, upon H plus we have already concluded that what should be the H plus, है ना. But it was having two cases, that's why I'm not writing this formula. Is it okay? And if they are asking OH minus, that is also an ion, no? It is always Kw upon H plus. Okay? So this was a typical calculation for an aqueous solution of H3PO4. They may give you H2CO3, they may give you oxalic acid, they may give you H2S, ऐसा कुछ भी दे सकते हैं. That's one case. ये जो केस 9 डिस्कस किया है ना, केस 9 के लिए हम लोग ब्रांचिंग कर सकते हैं पूरा. केस 9 इनकॉर्पोरेटेड इन केस 3 हम लोगों ने अभी डिस्कस किया है. You can have weak polyprotic acid along with some strong acid also. We can have weak polyprotic acid along with some another weak acid also. That was case 3, 5 and 7. वैसे ही बेसिस भी हो सकते हैं. So that's why अब उसमें जा नहीं रहे क्योंकि वो केसेस ऑलरेडी डिस्कस कर दिया. बट वी हैव अंडरस्टूड दैट पॉलीप्रोटिक एसिड के केस में प्रैक्टिकली वी कंसीडर फर्स्ट स्टेप एज द डोमिनेंट स्टेप और बाकी स्टेप्स को इग्नोर कर लेते हैं while we are calculating the H plus. ठीक है? I'll give you some questions. तो एक लगेगा केस 3 जैसा मिलता जुलता केस आ रहा है, दूसरा केस दिखेगा केस 5 जैसा आ रहा है, तीसरा केस दिखेगा केस 7 जैसा दिख सकता है। I'll give you केस 3 5 ओनली, 7 में नॉर्मली देते नहीं है वो। I'll give you that केस आल्सो, बट केस 10 भी साथ में ही लिख देता हूँ मैं, बिकॉज यू कैन हैंडल दैट इन द सिमिलर मैनर, जैसा भी केस 9 किया है, जहाँ H प्लस है वहाँ OH माइनस आएगा, जहाँ आना है वहाँ केटायंस आ जाएंगे ना। सो वी कैन हैव weak poly acidic bases in which we can have these type of examples and we can handle it in the similar manner, just H plus की जगह OH minus, anion की जगह cations. Okay, चलो that's one part. Now I'll be giving you some questions. देखो जरा ये questions कैसे दिख रहे हैं तुमको. Different cases I have tried to cover the varieties of questions related to weak polyprotic acids. Like this is the first question, try to solve this one. Any answer? Okay, pH के लिए you have got the right answer, बाकी calculation करो. Yeah, Chris, you have got the right answer for pH. Geet, you have also got the right answer. Hmm. Yes, I think you have got all the answers right. Harsh, your answers are right.
सर आपको व्हाट्सएप पे भेजूं?
इधर ही टाइप कर देना कहीं. बोल ही दे यार, इतना क्या है, बोल दे.
ठीक है सर, तो मतलब अभी OH माइनस का 10⁻⁻10,
ओके.
H2S माइनस HS माइनस का 10⁻⁴ और
ओके.
S2 माइनस का 10⁻13।
बाकी लोगों का.
सर मेरा
हाँ ओम बोलो. Tell me home.
सर मेरा pH 4 आ रहा है
Okay.
और OH माइनस 10⁻⁻10
Yes.
HS माइनस और 10⁻⁻4
Yes.
S2 माइनस 10⁻⁻14
14.
हाँ 14
Okay, let's see. So we have got पहली बात तो we have got mass in milligrams. So we need to take care of that, and volume in ml. That's why if they are asking that what is the concentration of H2S before ionization, so that will be, this is 0.85 gram. That much upon 34 will become its moles upon 0.25 will become its molar heat. And that's why if you calculate it, you will be getting, मैंने जानबूझ के set किया है, this is 0.1 m आ रहा होगा ना, ठीक है? So now this is 0.1 m. I'm calling it C. Now H2S, it is having just two steps, है ना? That's why it will be giving you H plus aqueous and HS minus aqueous in the first step itself. And then it is giving you HS minus aqueous giving H plus sulfide, है ना? And if you see K values are given, K1 is in the range of 10 raised to minus 7, K2 is in the range of 10 raised to minus 13. Now साफ साफ पता चल रहा है K1 is much greater than K2, first thing. Second thing, we know that due to common ion effect, suppression of ionization of second step will happen due to presence of H plus coming from the first step. Both of them will be suppressing each other's ionization, but जो ज्यादा मजबूत होता है, that imposes more effective common ion effect that we have learned, है ना? And that's why we'll be saying कि we'll say C into 1 minus alpha 1, तो this will become C1 alpha 1. देखो अच्छा, यहाँ पे मैं पूरा कैलकुलेशन करके दिखा रहा हूँ, so that somewhere if you are getting comparable ये ना, you will be very cautious with that. So यहाँ देखो, I always told you that in simultaneous equilibrium किस पे काम करना होता है?
The
You are
not
getting,
common one.
which is not common, है ना? तो what is not common is sulfide. ठीक है, तो मान लो सेकंड स्टेप का डिग्री ऑफ आयनेशन वाज अल्फा, ठीक है? सो नाउ यहाँ पे if इसका फॉर्मेशन वाज C1 alpha 1 या C alpha 1, if this was C alpha 1 in the first step, second step में ये C alpha 1 जो बना है that will become 1 minus alpha 2, ऐसा कुछ बनेगा. X में भी काम कर सकते थे, but just I wanted to show you कि जनरल कैलकुलेशन कैसे होता है. And then the C alpha 1 into 1 minus alpha 2 will be producing C alpha 1 alpha 2. तो नेट सिर्फ इतना नहीं लिखेंगे, we'll write C alpha 1, we'll write C alpha 1 plus C alpha 1 alpha 2. This is net H plus, है ना? Similarly, I have to write total H plus will be C alpha 1 plus C alpha 1 alpha 2. And this will be C alpha 1 alpha 2. This is the general calculation. Just to give you the idea कि if you have got advanced वाले level में, if you have got the comparable Ka values, तो we need to work in terms of that. But ये solve करना इतना आसान नहीं है. That's why they don't ask generally it for the solvable questions. But obviously concentrations अगर symbols में पूछेंगे तो we can represent it, है ना? That's one part. Now second part is, अब हम लोगों को calculation करना है, तो we have got enough sufficient good enough approximation that we can see that K1 is much greater than K2, and common ion effect वाला point already हम लोगों ने समझा हुआ है ना. So that's why after considering both the points, what we can say कि first step का H plus will be the dominant H plus, है ना? So we'll write, we'll first check it. Now मैंने बोला था कि check कर लेते हैं. So the checkpoint was, we'll always check under root K1 upon C कितना आ रहा है. तो if you see that is coming 10 raised to minus 7 upon 10 raised to minus 1. This is 10 raised to minus 3, which is less than 0.1. And that's why we can say H plus from acid can be considered as under root K1 into C. And that will be coming 10 raised to minus 4, which is greater than 10 raised to minus 6. इसलिए water का H plus can be ignored. So that's why if I have to find out the pH, I'll directly take minus log of 10 raised to minus 4, and that's why we'll say 4 will be the answer. This is the first part. Second part, it is asking about anions. So already we discussed that HS minus is very close to देखो नंबर से साफ साफ पता चल रहा है, दिस इज सी अल्फा प्लस सी अल्फा 1 अल्फा 2, दिस इज सी अल्फा 1 माइनस सी अल्फा 1 अल्फा अल्फा 2, है ना? तो ये स्लाइटली तो लेस होगा ना, दिस विल बी ग्रेटर देन दिस, बट अप्रोक्सीमेटली बिकॉज वी हैव इग्नोर्ड अल्फा 2 इन कंपैरिजन टू 1, दैट्स व्हाई वी कैन से कि दोनों बराबर है, दैट्स व्हाई वी आर सेइंग दिस इज वेरी क्लोज टू H plus itself, and which is 10 raised to minus. If I am talking about OH minus, that was simply Kw by H plus, and that's why it will become 10 raised to minus 10. Now, if I am talking about S2 minus, that is sulfide, we can write H plus into sulfide upon Hs minus is equal to K2, and then we can put, we know that ये दोनों बराबर लिया ना, तो sulfide is simply K2, which is given as 10 raised to minus 13. है ना? These are the answers for anionic concentration. Om, where was the mistake? What was the mistake for sulfide?
I calculated it wrong.
But calculation तो था ही नहीं ना.
मतलब पावर्स में मैंने मतलब नंबर्स उल्टे
Okay, तुमने
गलत
नंबर
दिखे.
रख दिया और गलत लिख दिया. Okay,
हाँ.
चलेगा. Now I'm going to complicate it. अभी तक कोई डाउट है तो पूछ लो, because the next question will be tougher than that, because I'm going to complicate it.
सर
Yeah.
तो मुझे HS माइनस का समझा नहीं, मतलब आपने जो
See, HS minus is being produced in the first step with along with H plus, and they are having equal coefficient. So equal production will be happening. Second step में that produced HS minus is going to be consumed, but that consumption is negligible, है ना? And that's why we'll say it will be almost. Why I'm getting these calls? Okay, so the point was कि HS minus, like देखो ना, once we have calculated sulfide ना कितना है 10 raised to minus 13 ना, what does it mean? Out of those 10 raised to minus 4 moles per liter HS minus, only 10 raised to minus 13 is undergoing ionization, है ना? We can definitely ignore that, ना? ठीक है? And that's why we are saying कि it is reasonable that we can consider H plus and HS minus is almost equal. ठीक है? तो if you ask me, तो H plus is like 10 raised to minus 4 plus 10 raised to minus 13 जैसा हो जाएगा approximately, and HS minus will be 10 raised to minus 4 minus 10 raised to minus 13. But वो 10 raised to minus 13 is so small in comparison to 10 raised to minus 4 that we can ignore it. We can neglect it. Okay, that was the point. Any other doubt? चलो नेक्स्ट क्वेश्चन देखते हैं, बिकॉज ये ऐसा क्वेश्चन था जहां वीक मोनोप्रोटिक एसिड की जगह आई पुट वीक पॉलीप्रोटिक एसिड. नाउ आई विल गिव यू केस 5 जैसा रेफरेंस, and I'll be putting two acids in which one of them will be weak polyprotic acid. Now try to solve this question.
Sir, I can assume the volume to be anything.
Hmm?
I can
हाँ
assume the volume to be anything. No?
हाँ, मतलब V 100 ml 1 liter whatever you want चलेगा. Okay, whatever we are discussing today, and then एक part theoretical section of ionic equilibrium I had discussed in geos. ठीक है, what I'll do ना, वो पूरा section का PDF I'll share with you, so that if you're clear about everything in that PDF ना, तो then we'll move ahead for salt hydrolysis. If you're having some doubt, तो we'll discuss that first and then we'll move to salt hydrolysis. ठीक है?
सर एक बार फिर से रिपीट करें ना.
क्या मैं बोल रहा हूँ कि टुडे वी आर डिस्कसिंग वीक पॉलीप्रोटिक एसिड, नॉर्मली है ना, पॉलीएसिडिक बेसिस वैसा ही रहेगा. उसके बाद आई जनरली डिस्कस द कंसेप्ट ऑफ एसिड एंड बेस, दो आर्रेनियस, ब्रॉन्स्टेड लॉरी, लुइस वाला. देन आई डिस्कस दैट what type of reaction we are considering, we can consider to be completed, what type of reaction will be partial only. एक लाइन बोला था मैंने, stronger acid reacts with conjugate base of weaker acid. All those things, concept of conjugate base, conjugate acid, वो पार्ट नॉर्मली आयनिक में भी मैं पढ़ाता हूँ. ठीक है, तो वो मैंने जिन्होंने जीओसी किया हुआ है उनको ऑलरेडी मैंने पढ़ा दिया. बट आई विल शेयर दैट पीडीएफ जो मैं आयनिक के टाइम पे पढ़ाता हूँ विद द क्वेश्चंस इन्वॉल्व, है ना. जस्ट गो थ्रू दैट पीडीएफ एंड इफ यू आर क्लियर अबाउट एवरीथिंग देन विल डायरेक्टली मूव टू सॉल्ट हेड्स. ठीक है, इफ यू आर हैविंग सम डाउट तो फर्स्ट विल डिस्कस दोस डाउट्स एंड देन विल मूव टू सॉल्ट हेड्स. इट इज जस्ट टू सेव द टाइम. इफ यू आर क्लियर तो बार बार क्यों डिस्कस करने का, है ना. ओके, क्लियर ना अनुराग?
सर मैंने आपको Cl- का आंसर भेजा.
ओके, Cl- का आंसर भेजा है. सबसे टफ क्वेश्चन तो तुमने अभी सॉल्व किया. किधर भेजा है?
सर चैट पे.
चलो ठीक है, वो राइट है.
अरे सर मैंने तो ऐसे गेस कर लिया.
बट यू डोंट हैव एनी बेसिस.
नहीं सर, लाइक आई वाज लाइक.
अपने को ये काम नहीं करने का है. एक होता है इन्फॉर्म्ड गेस, है ना. एक होता है इन्फॉर्म्ड गेस कि आई एम हैविंग रफली 98% आइडिया, देन आई कैन हैव दैट 1-2%. बट अदरवाइज जे एडवांस में तो बिल्कुल ये काम. इफ यू डोंट
नहीं
हैव इट,
मतलब जैसे H+ का कंसंट्रेशन और मतलब HCl विल डिसोसिएट इनटू H+ एंड Cl- ना.
यस
तो
यस,
लाइक अभी HCl इज अ स्ट्रॉन्ग एसिड एंड दूसरा अपना है. हाँ.
इट विल बी कंप्लीटली आयनाइज्ड.
हाँ, इट विल बी कम्प्लीटली आयनाइज्ड. और दूसरा कौन सा है, H2CO3, इट इज अ वीक एसिड. तो उसका H+ ज्यादा अफेक्ट करना नहीं चाहिए
इस पे
HCl के H+ पे.
ज्यादा नहीं करना ही नहीं चाहिए, बिकॉज इट इज
करना ही
स्ट्रॉन्ग
नहीं
एसिड.
चाहिए, इट इज स्ट्रॉन्ग एसिड.
जीरो
हाँ.
इफेक्ट, बिकॉज देयर इज
तो
नो
उसके
रिवर्स.
तो मतलब तो उसके हिसाब से तो इक्वल ही हो जाएगा ना, H+ और Cl-.
दैट्स ओके.
तो ये लॉजिक तो सही है ना. हाँ बस ऐसे ही किया.
The first point of mistake you will be doing if you are not considering this line, just after mixing you have to calculate the concentration. I told you many times, है ना. Whenever they are giving you two solutions are being mixed, गीत का चेहरा देख के लग रहा है कि उसने मिस्टेक किया है. So I'm telling you, that's why I ensure that कि 4-5 क्वेश्चन में से 2-3 क्वेश्चन तो ऐसे ही होने चाहिए जिसमें मिक्सिंग रहे. So whenever they are giving you the solutions being mixed na, always write that part just after mixing. Just after mixing, because the volume is getting doubled, concentration will become half. That's one point. या फिर दूसरे तरीके से, moles will remain same for HCl. So if it was having 0.4 as molarity, its volume was V, so 0.4 into V was the moles, and now the total volume is V plus V. That's why it will become 0.2. Similarly, H2CO3, that will become now 0.2 times V upon V plus V. That is 0.1 M. Is it okay? इसके बाद सारा काम कर. Now HCl का कोई टेंशन ही नहीं है. HCl is strong acid, so it will be completely ionized to give you H plus and Cl minus. So now if it was before ionization ये 0.2 था, तो ये 0.2 हो जाएगा और ये भी 0.2 हो जाएगा. Is it okay? Now, can we ignore H plus coming from H2CO3? And why is that?
So Ka is very less.
Very less means कितना? तो नंबर बताएगा ना कि वेरी लेस रहा कि नहीं.
Less than 1/10.
ओके, सो बेसिकली के से नहीं चलेगा. मैंने तुमको बताया अगर ये मेंस का क्वेश्चन है ना तो इग्नोर दैट डायरेक्ट. दे डोंट वांट यू टू सॉल्व द क्वाड्रेटिक इक्वेशन. सीधी सी बात है. बट इफ इट इज द क्वेश्चन फ्रॉम एडवांस, इफ यू रिमेंबर मैंने केस 5 जब डिस्कस किया तो पूरी कहानी बताई थी और बोला था स्ट्रॉन्ग एसिड से आने वाला क्या चेक करना है. इफ नॉर्मली ये हो जाएगा बट चेक कर लेना हमेशा ही इफ इट इज अ क्वेश्चन फ्रॉम एडवांस. तो H प्लस फ्रॉम स्ट्रॉन्ग एसिड इफ इट इज मोर देन इक्वल टू 1/10 ऑफ concentration of H plus from weak acid which was in absence of strong acid. हम लोगों ने देखा था 2 स्टेप चेक किए थे. मैं पूरा लिख ही देता हूँ अभी. सो जो पूरी कहानी हम लोगों ने लिखी थी वो क्या थी. इफ अंडर रूट के ए ऑफ वीक एसिड, के ए 1 लिख देंगे यहाँ पे, अपॉन सी, सी इज द कंसंट्रेशन ऑफ दिस, या फिर चलो इसको मैं C1 बोल देता हूँ, इसको C2 बोल देता हूँ. इफ इट इज दिस मच इज लेस देन 0.1 एंड ये नहीं हुआ तो फिर क्वाड्रेटिक में जाना पड़ेगा. एंड देन इफ C1, अच्छा इसको भी C1 नहीं बोलते, वी कॉल H प्लस फ्रॉम HCl को C1 क्योंकि H2SO4 में फिर गड़बड़ हो जाएगा. इसको आई हैव कॉल्ड इट C1. देन इफ आई एम हैविंग अंडर रूट K2 into K1 into C2 less than equal to 1/10 of C1, then only we can ignore H plus from weak acid. Then H plus total can be written as H plus from strong acid. I can create a case in which the acid, weak acid will not be that much weak and its contribution cannot be neglected, है ना. But normally ऐसे क्वेश्चन में अगर इतने सारे क्वेश्चन पूछे हुए तो डेफिनेटली दे डोंट वांट यू टू वेस्ट द टाइम सॉल्विंग द क्वाड्रेटिक, तो अजम्पशंस को वैलिड मानते हैं. ठीक है. तो यहाँ पे इफ यू चेक assumptions will be valid and then with that logic we'll say H plus total will be H plus from strong acid only and that is coming 0.2. So that is 2 into 10 raised to minus 1. So we'll say and ये 10 raised to minus 6 से ज्यादा है वो भी चेक कर लेना एक बार. So pH will be 1 minus log 2, that is 0.7. That's one part. Second part is H plus Cl minus पूछा है वो तो यहीं से आ गया. If it is asking Cl minus तो उस पे तो कोई फर्क नहीं है. That is 0.2 m. That is the answer. Now बाकी anions में अब क्या? What about
So
HCO3?
OH के लिए pH निकाल के कर सकते हैं ना, OH माइनस.
इतना भी नहीं करने की जरूरत है. Kw upon H plus is the OH minus है. तो OH minus is nothing but Kw upon H plus. So that is 10 raised to minus 14 upon H plus is 0.2. That's why it gives you 5 into 10 raised to minus 14. This will be answer. What about HCO3 minus and CO32 minus? Last time H plus को HS minus के बराबर बताया था. Can we do that now? क्यों नहीं?
तो इस टाइम H प्लस का concentration बहुत ज्यादा है ना.
H plus is coming from strong acid and that will impose common ion effect even on the first step, and that's why anion coming from the first step will become much less than H plus total, है ना. And that's why we can't apply कि H plus and HCO3 minus बराबर होगा. Now whatever we were doing for the remaining steps ना, we have to do that for the first step also. So what we'll do for weak acid, for H2CO3, we need to write every step and then we have to apply it. What we are saying, even the first step ionization will be suppressed due to presence of HCl, and that's why in this part we are writing Ka1 is 2 into 10 is to minus 7 दिया है क्या? This was how much? 2 into 10 is to minus 7 and 2 into 10 is to minus 11. So this is 2 into 10 is to minus 7. So what we are saying, कि its ionization will be negligible in presence of in presence of HCl, we are saying that at equilibrium, even this step will have C into 1 minus alpha 1 जो लिखा था ना, this will become very close to C. This one is 0.2, and that's why ये जो आ रहा है, this is C alpha 1, which will be much less than 0.2. And that's why whatever we were doing for the remaining steps, we'll be doing it for the first step also. We'll write H plus into HCO3 minus upon H2CO3 will be Ka1. And that's why if I have to calculate HCO3 minus, we'll be putting K1, which is 2 into 10 raised to minus 7. H2CO3 का concentration was 0.1 upon H plus is 0.2, and that's why it is coming 10 raised to minus 7. And that gives you idea कि कितना ज़्यादा suppress हो चुका है. Is it okay? अगर ये HCl नहीं होता ना, if you calculate H2CO3 का first step का ionization कितना होगा, तो 0.1 में it will be coming in the range of 10 raised to minus 4. ठीक है, अभी आ रहा है 10 raised to minus 7. तो ये स्टेप भी 1000 टाइम्स सप्रेस हो चुका है. हाँ क्रिश बोलो.
सर सी का वैल्यू क्या होगा?
सी का वैल्यू तो जो H2CO3 का कंसंट्रेशन था, दैट वाज द सी का वैल्यू.
तो
मैंने
0.1.
C2 इनिशियली लिख दिया था.
हाँ 0.1.
पॉइंट 1 है ना, वही तो लिखा है इधर, है ना.
हम्म.
Okay, now we'll go for second step. So we'll write this HCO3 minus is giving you H plus plus CO3 2 minus, and this step has K2 का value. K2 का value we have 2 into 10 raised to minus 11. Now in this step we'll write, अब इसमें ज्यादा डिटेल में जाने की जरूरत नहीं है, सीधा लिखेंगे at equilibrium, बिकॉज इसका आयनेशन और भी ज्यादा सप्रेस हो जाएगा. एक तो पहले इसका K कम है, दूसरा पहले स्टेप के कारण सप्रेशन हो रहा था, अभी तो स्ट्रॉन्ग एसिड के कारण बहुत ही ज्यादा सप्रेशन हो रहा होगा. एंड दैट्स व्हाई विल राइट H प्लस इनटू कार्बोनेट अपॉन HCO3 minus will be equal to Ka2, and that's why if it is asking carbonate, we'll write K2 का value 2 into 10 raised to minus 11. HCO3 minus just we have calculated, it was 10 raised to minus 7, and H plus is 0.2. So if you write that, you'll be getting 10 raised to minus 17. देखो और भी बहुत कम हो गया ना. And that's why we are saying कि बाकी steps को practically we can consider it to be almost suppressed. Is it okay? एक इंटरेस्टिंग क्वेश्चन दे रहा हूँ, ये ट्राई करके आओगे. एंड रिमेनिंग में आई विल शेयर दैट पीडीएफ आल्सो, जिसमें आई विल टॉक अबाउट दोस थ्योरेटिकल पॉइंट्स. जस्ट सी दोस पॉइंट्स. इफ यू आर हैविंग एनी डाउट, तो पहले स्टार्ट में विल रिजॉल्व दोस डाउट्स ओनली, एंड देन ओनली विल मूव फॉरवर्ड फॉर समथिंग कॉल्ड सॉल्ट हाइड्रोलिसिस, एंड देन आफ्टर दैट बफर सॉल्यूशन. ठीक है, आई एम शेयरिंग वन क्वेश्चन, इसको जरा ट्राई करना. दिस इज द स्पेशल केस जिसकी बात मैं कर रहा था कि कैन वी हैव अ केस इन विच सेकंड स्टेप कैन नॉट बी इग्नोर्ड इन कंपैरिजन टू फर्स्ट स्टेप. दिस इज द रियल लाइफ एग्जाम्पल. H2SO4 को आज तक हम लोगों ने क्या लिखा था? 2H plus plus sulfate.
स्ट्रॉन्ग एसिड ना.
It is not like that. Only the first step is, in the first step only, it will be behaving as strong acid. The second step, it will be behaving as a weak acid. Not very weak, but still, if there is reversibility, we consider it to be weak acid. Now, if it is asking you, it has given you 0.0 m, 1 m, 0.01 m aqueous solution of H2SO4. अभी तक जो सीखा था ना H2SO4 के हिसाब से, वो क्या सीखा था? विल से H प्लस विल बी डबल ऑफ 0.01, है ना, यही करते थे. दैट मींस 2 into 10 raised to minus 2. अब किसी ने pH बोल दिया, तो आई विल से 2 minus log 2, which will be 1.7. but this is now, with this thing we'll say this is wrong.
इससे ज्यादा आना चाहिए ना.
pH,
हाँ.
बिकॉज H प्लस कम मिलेगा, है ना, तो pH इससे
हाँ.
ज्यादा आना चाहिए डेफिनेटली. ठीक है, तो एक बार ट्राई करके देखोगे, एंड आई विल बी शेयरिंग दैट पॉइंट जो मैंने बोला, थ्योरेटिकल पॉइंट जो है, आई शेयर दैट पॉइंट. उसको देख लेना एक बार, कोई डाउट रहे तो पूछ लेना, एंड नेक्स्ट क्लास में विल डिस्कस दैट आल्सो. ठीक है, कुछ लोगों का क्लास भी रहता है, तो आई एम लीविंग यू. इसको ट्राई करके रखोगे. टुमारो इटसेल्फ वी हैव क्लास, है ना, तो कल इसको भी डिस्कस कर लेंगे, एंड देन अगर कोई कंसेप्चुअल डाउट रहेगा तो विल डिस्कस, एंड देन विल मूव टू सॉल्ट हाइड्रोलिसिस. वेरी इंपॉर्टेंट. ठीक है, चलो. क्लोज कर. ओके, बाय एवरीवन.
बाय सर, थैंक यू.